We begin with work done on the club by me because I'm the one swinging the club. As we know, work is the change in kinetic energy, and in this case the kinetic energy is initially at 0 because the golf club is not moving when it is set up to the ball before I swing. And after I'm swinging, during the time of impact, the club is moving at 37.28 meters per second, which gives us a final kinetic energy of 287.69 joules. The work is equal to the final kinetic energy minus the initial, giving us a final work of 287.69 joules.
To show the conservation of momentum, the initial momentum of the system must be equal to the final momentum of the system. So we calculated the initial momentum of our system, which is just the golf club swinging because the ball is stationary, to be 15.43 kilograms meters per second. And we calculated the final momentum of our system, which is both the club swinging and the ball moving, to be 12.22 kilograms meters per second and 2.457 kilograms meters per second, which equals a total of 14.68 kilograms meters per second. And our initial momentum of 15.43 kilograms meters per second does not equal our final momentum of 14.68 kilograms meters per second, so momentum was not conserved in this collision.
Here are our other calculations for the flight of the ball after the collision. Now, the initial velocity is 53.82 meters per second with a launch angle of 17.3 degrees from horizontal. Now, we know that the initial velocity in the y direction is 16 meters per second, and because the final velocity is the opposite of this initial velocity, we can find the time of flight to be 3.26 seconds. Now, to find the max height, we know that the final velocity in the y direction is 0 meters per second, and the total time of flight at this point is half that of the total flight. Now that we know that, we can find a maximum height of 13.03 meters. And in addition, the velocity in the x direction is a constant 51.39 meters per second throughout the flight. The conservation of energy during the flight of the ball involves the transfer of kinetic energy to potential energy and vice versa. Now, the total energy is the sum of the kinetic and potential energies. Now, the potential energy is initially 0 because the ball is at ground level. The kinetic energy is 66.11 joules to the ball's initial velocity of 53.82 meters per second. Now, as the ball travels upwards, it transfers some of this kinetic energy into potential energy as it loses velocity and gains height. Now, the potential energy at the top of the parabola is 5.83 joules, and the kinetic energy at the top of its flight is 60.28 joules. Now, the total energy is the sum of these two, which equals 66.11 joules. Now, as you'll notice, this is the same as the total energy initially of 66.11 joules, so energy is conserved.
To calculate our coefficient of restitution, we set the second object as being the golf ball and the first object as being the golf club. And the coefficient of restitution is a measurement of the elasticity of a collision, and 1 is perfectly elastic while 0 is perfectly inelastic. And if the coefficient of restitution is 1 and it's perfectly elastic, energy is conserved for the collision. And so our coefficient of restitution equation ends up being 53.82 meters per second minus 29.51 meters per second, all divided by 37.78 meters per second minus 0 meters per second. And this gives us a coefficient of 0.6521, which means that we lost energy because it was not equal to 1. So we calculated our percent energy lost in the collision because we had a coefficient of restitution of less than 1. And we calculated that our final energy after the collision was 246.37 joules divided by our initial energy of 287.7 joules, which gives us 0.8563, which is equivalent to 85.63% energy retained. And then if you subtract that number from 1, you get the amount of energy lost, which ends up being 14.37% energy lost from the